Hello friends, I am Dr.V Associate Professor, Shivaji Arts, Commerce and Science College, Kannada. Now in last lecture, we studied about the electric field lines and how field lines are coming from positive sides and it goes to negative sides. Now today we discuss about the electric flux. Now the electric flux is to quantify the number of the field lines passing through the surface. Yes, the electric flux through the surface area is defined as the product of electric field and surface area of the projected in a plane. The electric flux is directly proportional to the number of the lines drawn, since the electric field strength is proportional to the density of the field. Now, Gauss law, it is most important in electrostatic. According to this law, the electric flux phi E through any closed surface is equal to the 1 upon epsilon naught times the net charge Q enclosed by the surface. Phi E is equal to, that is flux enclosed, is equal to the charge divided by epsilon naught. The law can also be expressed that the integral of the normal component of electric field outward electric flux over a closed surface of any shape in the electric field is equal to the 1 upon epsilon naught times the net charge enclosed by the surface. That is, surface integral of E means electric field dot n into ds. ds is the surface area, which is equal to the q upon epsilon naught. Now this is surface integral of E dot ds is equal to q upon epsilon naught, where this integration over closed surface represents the surface integral taken over the whole of the closed surface, and n is the unit vector drawn normal to the surface element ds. Now, according to Gauss law, here we consider two cases. Case 1 is for internal point. Here in figure we consider, here Q is the charge, positive charge, and P is the point which are at a distance R from the O. To prove Gauss law, we have begin with the case when the source producing the field is a point charge plus Q situated at O inside a closed surface as shown in figure. Now consider an infinitesimal elements ds of the surface at point P. Let OP is equal to R as shown in figure. Then surface integral of E dot n into ds is the electric field over the closed surface. Now this electric field at point P is given by the equation 1 upon 4 pi epsilon naught Q upon R cube dot R. So this surface integral E dot n into ds is equal to 1 upon 4 pi epsilon naught q into surface integral of r dot n upon r cube into ds. Now it can be seen that the quantity r dot n dot ds upon r gives the projection of the area ds on the plane perpendicular to r, and therefore projected area divided by r square is equal to d omega, that is a solid angle. D omega is called a solid angle. Now substitute this value, we get integration s e dot n into ds is equal to 1 upon 4 pi epsilon naught q surface integral dot d omega. But d omega integration over surface integral closed surface area d omega is equal to solid angle and its value is equal to 4 pi. So substitute this value of 4 pi, we get surface integral over closed loop E dot ds is equal to q upon epsilon naught. Now this is the Gauss law.